So in 5.4, we're now going to combine this graphing we've been learning and the concept of slope with constant of proportionality, K. We're going to find K from a graph. So we're going to first remind you how to find a slope. So this one starts at 0, 0. The zeros are missing there. But 0, 0. We go along. There's a good intersection. There's a good intersection. There's another one. All right, so you go straight down and straight over. The rise is 1, the run is 3, the slope of that one is 1/3. This one over here, I'll do it in blue. So there's a good intersection. No, there's one, there's one, there's one. We know, like, I didn't graph that one all that great, but we know the correct ones because they're going to have an equidistant pattern. So once again, you draw your triangle, you go down, and even with the previous one, to get your ramp underneath or right triangle underneath, you have a rise here of 3, you have a run here of 1, and so the slope of this is rise over run, which is 3 over 1, which is 3. That's a slope of 3. The other one was a slope of 1/3. So what we're going to do now is we're going to translate that concept to the real world. So this is a graph of a tree growing, right? There's the feet it's growing, and here are the years it's been growing. So in 1 year, it grew that much. And what this graph, they're going up by 5s. So the scale today is going to be a big thing. And as I said a couple of lessons ago, we're going to look at that scale very closely. But we're still going to be finding the slope, and we're going to show you that. Right. So let's start with the one on the left. So the one on the left starts with 0, 0. And let's find the scale here. All right, so from halfway to 24 is 12. So we're going 12, 24, 36, 48, 60, and so on. Now, we're going to find the slope here. You know, here are good intersections. And I showed you this one. I didn't graph it all perfectly, but this is trying to hit every single one of these. And so the slope here would have been 1, right? Now, let's look at our scale, though. Along the bottom, right, 1 box is worth 1. So the run here is 1. But what is the rise? It's 1 box, but we have a different scale than yesterday. What is 1 box worth on that graph? You would say the rise is 12, right? Because each box is worth 12. So you would say the slope here is 12 over 1, which is 12. Now let's look at the one next to it. The one next to it, let's get our good intersections first, right? 0, 0 is a good intersection. And then I go along, there's 1. And this should be equidistant, even though I didn't draw it great. That is that. But we also need to look at our scale. Halfway to 10 is 5. So we're going 5, 10, 15, 25, and so on. So we're going to draw our right triangle. I'm pretty consistent that the bottom will stay 1. So the run here is 1. If it's 1 box long, that's 1. But the rise here is not 3. It's 3 boxes, but how much is a box worth? Well, a box is worth 5. So the rise here is 15. So the slope here is 15 over 1, or 15, even though it looks like 3 over 1. Let's see if we get that. So find the slope here. You might want to do this first, right? Each box is worth 6. Halfway to 12 is 6. So then we're going to get our good intersections. We're going to go along here. Anywhere, you pick any intersection, you go over to the previous one. Now along the bottom, each box is worth 1, so the run here is 3. What is my rise? 1 box is not worth 1. What is 1 box worth? 1 box is worth 6. So this looks like it's 1/3, but it's actually 6/3, or 2. So we're going to find the slope. If the line goes through 0, 0, it turns out the slope is the constant of proportionality. if it goes through 0, 0, k and slope are the same number. So let's see what we're going to do here. Find the constant of proportionality k and write an equation. We can only do that if it starts at 0, 0, right? Only proportional relationships start at 0. If it goes through 0, 0, I should say that better. If it goes through 0, 0 and it's a straight line, it's proportional relationship, and then we can find the slope, and the slope will be k. So let's do that. So let's start. So I gave you the good intersections, right? So we can go straight down and straight over. Now, once again, along the bottom, each box is worth 1. And so the run is 2. But what's our rise? It's 1 box, but what's a box worth? Halfway to 24 is, in fact, 12. So the slope here is 12 over 2, which is 6. And that means k is also 6. Okay? Because this is a line that starts at 0, 0, slope and k are going to be the same number. Now let's fill in this table and see if we can learn more about this. So, right, so we know that one of the points was 0, 0, but I didn't put a dot on that intentionally because we're going to ignore that. So when x is 2, what was y? Y was 12. When x was 4, what was y? It was 24. When x was 6, what was y? It was 36. And when x is 8, what's y? 48. And lastly, the last one I did was x is 10. What's y? We're going up by 12s. All right, y is 60. So find the constant of proportionality k and write an equation. All right, so what's the equation here? Well, remember, it's in the form y equals kx. So it's y equals 6 times x. Is that what happened in the table? Was y always 6 times what x was? Yeah. In fact, I didn't really have to read these points off the graph. I could have just taken all these x's and multiplied them by 6 once I have the equation. Right, so we're trying to tie all these things together. All right, so this is a graph of Jerry's pay. We're going to write an equation that describes Jerry's pay versus time. It's a proportional relationship. It starts at 0, 0. And let's see, it looks like every intersection here is good. All right, so let's pick, all right, so let's find the run is 1. What's the rise? It's not 1, right? A box is worth 12 again. So the rise is 12. So Jerry's pay, the slope here, but let's go over this. Right? The slope here is 12. What does that mean? It means k is also 12, the constant of proportionality. What's the unit rate? What is Jerry getting paid every hour? Remember, the k is also the unit rate. He's getting paid $12 per hour. So this is the big idea of 7th grade. That those three numbers are always the same in a proportional relationship. The slope, the constant of proportionality, the unit rate in a proportional relationship are always the same number. You have one of them, you have all three of them in a proportion. Okay, so what is the equation, right? We're not going to use y and x. It says P, pay, right, that is 12 times h. That's our equation. He's getting paid $12 for every hour he worked, right? He works 10 hours. This number better be 120 over here, right? We're going to 12 times table. This one's 108. Yeah, that's 120 because he works 10 hours. He makes $120. He makes 12 times the number of hours. That's tying it all together. Let's do another one. We're going to practice this. So this starts at 0, 0. It's a proportional relationship. There are good intersections. So we can do it right here. The run this time is 2. It's 2 boxes. Each one is worth 1. The rise is 1 box, but a box is worth 6. Right? So the slope here is 6 over 2, which is 3. The slope is 3. That means k is 3. That means the unit rate is, I didn't put dollars, but I should have. Unit rate is $3 per pound. I'll use LB. All right, they're always the same number. So now let's write an equation. It says use C for cost is 3 times, it says use P for pounds, is C, cost is always 3 times the number of pounds. And we can always check our work here, right? So say you have 8 pounds, it better go with 24, does it? Sure does, right? The cost is always 3 times the number of pounds. Let's try this one. This is a road trip, miles per hour. So it's proportional. We're at 0, 0. And there's a good intersection. There's another one. The slope here, all right, the run is 1. We could do it anywhere, right? And the rise is 2 boxes, but each box is worth 25. So the rise there is 50, right? So the slope is 50 over 1, which is 50. That means K is 50, and that means the unit rate is also 50. 50 what? 50 miles per hour. Right? This is miles per hour. They're all the same. We're going to write an equation. M for miles is 50 times the number of hours. Right? If you have, so notice the graph. This graph, by the time you get to 10, is gone. Right? But we don't need the graph. We have an equation. Right? At 10 hours, he's going to have gone 500 miles. We can even do, right, 20 miles, assuming he goes exactly 50 miles per hour forever. I think that's 1,000 miles he'll go. So once you have the equation, you actually don't need the graph to get your data. Either one can get it though. All right, so find the constant proportionality of graph A and write an equation. Okay, so that's red, so I'll do this in red. So the run is 1, the rise is 3 boxes. Well, what's a box? 5, 10, a box is worth 5, so the rise here is 15. All right, so the slope is 15 over 1, 15, which means K is 15. Okay. Find the constant of proportionality of graph B. Oh, I didn't write the equation for graph A, so let me finish that. So it would be dollars equals 15 times hours. So the unit rate here, what does that mean? The unit rate was $15 per hour. All right, so this must be some wages. We're going to assume it's wages, dollars per hour. All right, so now we're going to do B. I didn't read it carefully. So now since that's in the way, I'll go over here. Right, the run is 2 boxes. The rise is 3 boxes. Once again, the rise is 3 boxes, but each box is worth 5. So the rise is 15. So this slope is 15 over 2. Right? And so what's K? K, right, is 15 over 2. And you can leave it that way, or you could write 7.5, either one. You're not going to write 7.5 though. Even though K couldn't be written 7.5, right? You have to write an equation, and we're not going to put 7.5 in an equation. The equation of that one is D equals 15 halves H, or D equals 7.5 H, whichever one. Those are both good. So now I think we're going to compare those. Which costs more, A or B? Oh, dollars per hour, which costs more. So this maybe was a rental. I should have labeled this because it says which costs more. I thought it was a wage. So it's a rental. So which costs more, A or B? Well, the one with the higher unit rate. The higher unit rate is A. Now, we could have known that without all these calculations because A points more toward the ceiling. The one that points more toward the ceiling has the higher slope, has the higher K, has the higher unit rate. The flatter one, the lower one, B, well, whatever the one is lower, has a lower unit rate, a lower K, a lower slope. So this one's runabout. That's very clear. So let's write an equation. So its proportion starts at 0, 0. Here are our good intersections. The run here is 1. The rise is 3 boxes. What's a box though? A box is worth 12. So 3 boxes is worth 36. So the slope here is 36 over 1. 36. K is 36. And the unit rate must be I didn't put dollars, I should have. Unit rate is $36 per hour. And I should also be less sloppy. So now I have to write an equation. It says use C for cost. C equals 36 times the number of hours. Find the constant proportionality from the graph and write an equation. Okay, so there's 0, 0. I did a lot with 3 boxes there. Maybe next year I will do fewer of those. But halfway to 24 is 12. This is worth 1. So the run is 1. 3 boxes. Each box is worth 12. This is 36. The slope here is 36 over 1, which is 36. And it's y equals 36 times x. So, right, 3 times 36 should give us this number, right? What's 3 times 36? Oh, it's 108. Is that 108? Yeah, that's the next number on the 12 times table. But now, right, if x is 10, right, it's 360. It's some place way up there. Good luck with the homework.